Hi everyone, today we are going to learn about what is root functions of a matter, threshold frequency, threshold wavelength, and the quantum theory for photoelectric effect. So we know that quantum theory states that light energy is actually in quantized form, where in the expressions of H and F. So inside the photoelectric effect, we know that a photon when incidents on the matter surface, these photons will absorbed by the electron. So each time for an electron, it only can absorb a photon at a time. It cannot absorb 2 or 3 photons. So this electron can only be escaped from the metal surface when the frequency exceeds the threshold frequency. In other words, that there is no emissions of photon if the photon energy less than the work functions of the matter. So what is actually work function? So work function is actually the characteristics of a matter. So every matter have different work functions. So work functions means that the minimum energy required to remove an electron from that matter. So let's say your work functions for silver at here. Silver is 4.26 eV. So if the photon energy is less than this 4.26 eV, then no emissions of photon electrons. So no photoelectric electric effect will be observed. Okay, so this is called work function. So every different metal has different work function. So from this table, you will see that silver has the highest work function compared to the potassium. Potassium has less work functions. So means that we only have a smaller frequency in order to let the electron escape from the metal. Okay? If there is an emission of photons, means that the photon energy is greater than the work functions or equal to the work functions. So let's say the HF, the photon energy is equal to work functions, means that the energy of the photon is just enough for the electron to emit from the matter but cannot move. Okay? So this frequency that causes the electron to be emitted from the matter, this minimum frequency, which is equal to the HF equal to work functions, we call it as threshold frequency. So threshold frequency is the minimum frequency of light that can emit photoelectrons from a matter. So how do you calculate? By using this equation. So you know that HF is the minimum energy for a photon to cause the electron to be emitted from the metal surface. So HFT will be equal to work function. So FT will be equal to W divided by H. So this one is the expressions for your threshold function. So your threshold functions have this formula, W over H. Okay, W is the work functions for matter, so it's a constant or a characteristics of the matter. Then what is threshold wavelength? So we know that threshold wavelength is actually, so C is equal to F lambda. So now you have minimum minimum frequency to cause emissions of photoelectrons from a matter. Then it will be, in other words, it will have a maximum wavelength to cause the photoelectron to be emitted from the metal surface. So threshold wavelength is actually the maximum wavelength for the light causes the emissions of photoelectrons from matter. So lambda T will be equal to C per Ft. So this is your expressions for your threshold wavelength. So let's say if you have a frequency that lower than this threshold frequency, then there will no do not have any photoelectrons emits from the matter. In other words, if you have the wavelength which is greater than the maximum wavelength or the threshold wavelength, then there will be no emissions of photoelectrons. Okay. So from this photoelectric effect, we will have an equation. So let's say now the photons that you provided by the light source is now greater than W. It's not only equal to W, it's greater than the work functions of a matter. Means there will be an extra energy. So HF equal to, now it will have, this HF will be used to overcome the work functions of a matter, and the extra energy that left behind will become the kinetic energy of a matter. So this kinetic energy will become the maximum kinetic energy for a photon electron to be emitted. Okay? So it means that when you have extra HF, more than your HF is greater than your work function, then your electron will move. So what is Einstein's photoelectric equations? So from previous slide or previous okay, so what is actually Einstein's photoelectric equation? So we know that these photons will transfer the energy to the electron. Let's say your HF provided by the sources or the electromagnetic wave is greater than the work functions. So when it's greater than work function, means this HF will have an extra energy. So the HF will be split to, that is used for work function that help the electron to emitted from the metal surface, and the extra energy is the energy provided for the electron to move with a maximum Ke. Means it will have enough energy to emit with some velocity. So maybe if HF is equal to W, then this photon will do not have extra energy for the photoelectron to move. Means the photoelectron just emits from the surface and keep at rest at the metal surface. But if your HF is greater than W, then this HF will give extra energy to the photoelectron and causes the electron to move with some velocity. So in other words, Einstein's photoelectric equations can be written as this. Okay, HF is equal to W plus E maximum. Here, the E maximum here means that the maximum kinetic energy in photon, not photon, photoelectron. Well, W is the work functions of the metals. Then F is the frequency of the photon. Okay, so from here we know that the maximum energy of photons, okay, sorry, already on. So HF is equal to W plus E max. So if you see that the maximum kinetic energy can be written as these expressions minus W. Okay, if you see these relations and you draw a graph, so you'll find that E maximum or the Ke maximum is directly proportional, it's not directly proportional, is depend on the F. So when your F is increased, then your E max will be increasing. Okay. So if your F increasing, then your E max is increasing. So if you look at this diagram, this graph, so you'll find that this one will have F increase, then E max increase. So from here, you also notice that the gradient of the graph, E max versus F, you will have gradient which is equal to the Planck constant, and the y-intercept here is your work functions, and the x-intercept here is the threshold frequency. So when your so it means that when your frequency is greater than threshold frequency, only the photoelectron will be moving in some speed. So if not, there will not have enough energy to let the photoelectron move in certain velocity. So from here you can see that since kinetic energy is equal to half mv square, so V will be equal to square root of 2hf minus W over M. So in other words, you will have a B maximum which is equal to square root of 2hf minus W over M, or you will have a minimum velocity which is equal to 0. Okay, so this is your maximum kinetic energy for the photoelectrons. Okay, that's it. So from here we know that the maximum kinetic energy is actually depend on the frequency. Okay, so it proved that from the previous lesson that we only said about maximum K is depend on frequency, but why? So we can prove that by using this equation. We can show that E is actually depend on F. Okay, and from graph you know that when F increase, then E will also increase linearly. Okay, next. So how we using the quantum theory to explain the photoelectric effect? So why the emissions of photoelectrons is instantaneous and there is no waiting time between the instantaneous light and the emissions of electron? Because the energy of the photon is in packets. So when it is absorbed by the electron, it is absorbed at once, in only one time. So it will take the whole packet and leave if the energy is enough. But if the electron doesn't receive enough energy, means the packet that the electron receive is not enough, then it cannot be escaped. So it will just constantly, it will stay at there forever and ever. But if the packet is like you get a bag of food, then you are happy, then you can go. If you are not happy, then you just stay there and very sad. Something like that. Okay? Then the effect of increasing the light intensity on photoelectric current. So we know that the intensity doesn't affect the photoelectrons emissions, but it will affecting the rate of emissions. Means that when you have higher intensity, then the photoelectric current will increase. Why? Because that we know that power of the power of the light source or the source of electromagnetic is equal to NHF, right? So if you don't know this one, you can refer to the lesson that I posted in YouTube, and the link is at the description box. Okay, So P is equal to NHF, and we know that P is also equal to I times A. So when you equal these two equations, you will get that NHF is equal to IA. So when you have different intensity here, so when your intensity increase and you are still using same light, means you have same frequency. So this one is constant. HF is constant because F is constant. So this increasing of intensity will cause N to increase. So means that in the number of photons emitted in 1 second will be increases. So when N increases means more electrons is emitted, then photoelectric current will be increases. So in other words, I will increases. Okay, is it clear? So the increases of light intensity doesn't affect the emissions of photoelectrons, but it will affect the rate of emissions of photoelectrons. Mean it cannot determine whether it will emit or not emit the photoelectron, but when the photon is enough to cause emissions of photoelectrons, then intensity will increase the rate of the emissions. Okay. Then another things that your quantum theory used to explain this, the effect of increasing of the light frequency at constant intensity on the photoelectric current. So let's say you increase the light frequency, but you maintain the intensity. You use the same intensity. So from the previous equations, here P is equal to NHF and P is equal to I times A. You have NHF is equal to IA. Now F is changing. F is increased, but I is constant. So if this one is constant, this is constant, of course area is always constant, then this one is increasing. So in other words, F will causes the N to be changed. Okay, it will change the value of N. So N is inversely proportional to your F. In other words, when your F increase, N will decreases. So when the rate of emissions for the photoelectron decreases, the photoelectric current will decreases, because now in 1 second the number of photon electrons that emits is decreases, become less. So current will decreases. Okay, so the rate of emissions of photoelectron decreases and the photoelectric current decreases. So this is how do you use the quantum theory to explain the photoelectric. Okay. So from what we have learned in previous chapter, we know that the light can be exist as a wave nature and also particle nature. So for wave nature, light has wavelength. In other words, this wavelength can be used to explain the interference pattern and diffraction pattern. So you can see interference and diffractions. If you use particle, it cannot have interference pattern or diffractions because there is no superpositions of particles, no. So wave nature is used to explain interference and diffractions. And in wave nature of light or wave theory, remember, light energy is a continuous energy. But for particle nature of light, so in particle nature of light, this is used to explain the photoelectric effect, where the light energy is in quantized and is in discrete order, where the light energy we call it as a photon with a multiple of HF. It comes in the packet. It is not continuous. So this is the difference between the wave nature and particle nature of light. So I hope you understand the difference between the light as a wave and light as a particle. So see you in my next video. Thank you.